Okay, so we have this equation. I'm going to get everything in the equation on the left-hand side. So I need to subtract 3x from both sides. And then subtract 3x from this side also. So what I want to do then is rearrange it so that it looks nice and neat. So x squared minus 3x minus 18 leaves me equal to what if I took 3x away from there? 0. Alright, so now I have this where we have this little part right in here. Let's see. Click on this. This. A little slower when I'm trying to record.
That's cool.
Well, what have we done with that? KLE.
Made it a big equation.
Huh?
Made it a big equation. Wait, what did you ask? You said what?
Are we used to seeing this somewhere,
Yeah.
Heidi?
It's like a binomial or trinomial.
Yeah, it's the trinomial that we factor down to two binomials. Because it's equal to 0, because this equation is equal to 0, we're going to be able to actually solve for the values of x. Okay? We simply factor this down like we've been doing with it equal to 0 still. We're going to have x and x. Signs are going to be different. And we need the factors of 18 that have a difference of 3. Factors of 18 that have a difference of 3. 6 and 3. 6 goes with the sign because the bigger number goes with the sign. Now follow along here with me. Remember the other day when we were doing our division of polynomials and we used the synthetic division?
Yeah.
And we found that 0 value for our divisor? Yeah. If I had this set of parentheses and it worked out, if I plugged in a number and it worked out to be 0, 0 times whatever this is would give me what?
0. She's not writing a note. Is that dangerous?
It's like her life.
So if this equaled 0, the total of this was 0. 0 times whatever I had here would give me 0. So what number gives me a value of 0 in here? Negative 3. So my answer, one of my answers is negative 3. Since I have the x squared term, I didn't mention this, but since we have the x squared term, that means you're going to have two answers. Two different answers. It could be the same number. Most time it'll be different. Forget this now. If I could make this quantity 0, wouldn't the total product be 0 also? So what was the value I could put in there for that to make it 0? Positive 6. And that would give me a true statement one way or the other depending on which number I plugged in. Keller.
So it's always going to have to equal 0?
We always want to get this set up equal to 0 so that we can find the value to put into these that will make these products 0 and give us a true statement then. Heidi.
Will there always be two answers for x?
Always no. If your binomial ends up being the same, if the two binomials are the same, then it would be the same number. But that's the only time. Otherwise, they are different. Morgan.
If you put the negative 3 and the 6 out of order, is the answer wrong?
No.
Okay.
It's not an ordered pair. It's just those are your two values. So if you would have set it up so you had x minus and then x plus, you have the 6 listed first, that's irrelevant. As long as you have those two answers, it doesn't matter.
Okay.
Oh, eventually you're going to have to graph.
No. No, well, eventually yes, but not this year. You'll graph stuff like this later. Can you foreshadow? Morgan, what does foreshadowing mean since you were reading?
Foreshadowing means like showing something that'll like happen.
Yes.
It kind of gives you a hint of what's going to come.
You can see what's going to happen. Right? Isn't that foreshadowing reading expertise?
Don't know.
When you watch a movie, aren't you usually thinking, ooh, there's a hint of something that might come when the music changes? You can tell. Well, I want you to do a little foreshadowing here with those two values. They're not in the right order to do things like we normally do, but can you see a connection between these two? Kelly? Okay. Morgan?
When you have 425s equals 100.
Yes, Morgan.
Okay.
Isn't like the 25 and 8 equals 5? Yeah.
What are you talking about though?
Okay, it's the square root.
Square root. Can we take square root of both of those?
Yeah.
Yes, you take square root of both of those ideas evenly. So let's get this negative 4x squared moved over here, or you could have moved the 25 over to here, either way. But I'm going to take and add 4x squared to both sides. That gives me 4x squared minus 25 equals 0. And that is then a situation where we have a difference of 2 squared. And we can factor that to a binomial, to two binomials. This would be, what's the square root of 4x squared? 2x and 2x, plus or minus 5 and 5. Now we have a coefficient with our variable, so this is going to change up just a little bit, but it's still easy, and once we do the first one, then we'll just use the pattern that develops from it. We need to find what makes this 0. So I'm going to come up here, 2x plus 5 equals 0. How would you solve for x from pre-algebra on that? This is pre-algebra, way pre-algebra ago. Okay, Kelsey, forgetting all your names.
Or subtract 5.
Subtract 5 is the first step, so 2x equals negative 5.
Divide 2.
And then divide by 2.
Negative 2.5.
So x equals negative 5 halves. That's what would make that value inside this first parenthesis 0, right? That's what we're doing. That's why we solved it this way. 2x plus 5 equals 0. What would x have to be to make this 0? Negative 5 halves. So x is equal to negative 5 halves. Look at these two digits and the sign and tell me the pattern that develops out of that.
Oh, it's the square root. It's like the 2 and 5.
That's where they came from the previous step. But now I'm solving. On the previous problem, we just put negative 3 and positive 6. Now I need to know, right, looking at this, we ended up with negative 5 halves as our answer to make this value 0.
There's just 5 halves.
So what would our answer be for the other one? Positive 5 halves. It's the opposite sign. And then if you have a coefficient with your variable, it's the constant over the coefficient. So 5, it's opposite of this, so negative 5 halves and positive 5 halves are your answers. Who's first?
Me.
Yes, alphabetically Kelly comes first.
Okay, is it negative 5 or positive 5 halves on the left side?
Okay, go ahead, sorry.
Yeah. Is it because there's negative over there? Is that why it's positive?
Right, if you were to solve that, wouldn't you have to add the 5? So it'd be 2x equals a positive 5. And so then divide by 2, 5 over 2. Morgan.
Well, when we did the first one, we just took what to make it 0. Wouldn't you just put that over whatever coefficient x has?
That's right.
Because the coefficient, the implied coefficient there is 1.
Right. So 3, negative 3 over 1.
It's just negative 3. So all of them are like that.
Yeah.
Okay.
Yeah. Heidi.
Why would you take like the first one? Why would you take 2x minus 5?
I just use that one as the example.
You always have to do the first one.
You do both. You're finding the value for. The reason I showed the first one, Heidi, was to show and develop the pattern of the answer. So now, whenever you get to this point, hopefully, in the future, you won't have to solve anything. You'll just go, okay, it's the constant over the coefficient and then the opposite sign. You don't have to solve those. You just know that's the answer. Shortcut. We like our shortcuts here. Sydney, what do we do first on this one?
Yes, Sydney.
I just hate you guys. It's not very nice. I bring the x squared to the other side.
Okay, by doing what?
I'm going to add it.
Okay, so we add x squared to both sides. So x squared, and this is already a positive x, so plus x minus 56. I'm putting them in descending order, and that leaves 0 on the right-hand side.
Can we make it x squared minus 56x?
No, you can't combine those. Why can't we combine those? Huh?
There is addition in between.
There's addition between them. They're not like
subtraction.
terms. Well, it's subtraction between them, but they're not like terms, so you can't combine them. Alright, so then we have a trinomial. Let's factor it. 2 binomials, that's x and x. The signs are going to be different. The factors of 56 that have a difference of 1. 8 and 7. All that beauty and progress shows.
Why doesn't the 8 go with minus?
Because the bigger number goes with the first sign. Because we have to have a positive 1 result. When we multiply back through, it gives us a positive x then. Positive 1x. Jack. So what would x equal?
Negative 8
Mm-hmm.
and positive 7.
That's right. Okay. So there's your answers. Kaylee. And there's a lot of choices when I say Kaylee, but I'm talking about load. What's the first step? How? Okay, so 3x squared minus 6x minus 9 equals 0. Kaylee, and there are plenty of choices. Egbert, what do I do now?
You factor the triangle.
Almost. We're not quite ready.
Don't we have to like get rid of the 3 and all of it? Like, don't we have to divide 3 out of all?
Very good. Good job. Factor the 3 out. X squared minus 2x minus 3. And Kaylee. Augustine. Yeah, that was foreshadowing, wasn't it? Alright, what are we going to do now?
You find the thingy bobber.
And what do we call the thingy-mabobber?
Thing like trinomials or something like that.
Factor the trinomial to
Yeah, binomials.
binomials. Okay.
Why do you have to equal 0 again?
Put an x.
I can't just drop it
Why not?
because it's an equation. If it's part of the equation. If I drop it, then all of a sudden it's not an equation anymore, and it's not equal to something.
I just said that. 0 is nothing.
in order to solve, children, in order to solve for x, you have to have an equal sign so that there's something to solve for. Otherwise, it's just an expression, and that's what we've been doing is we've been factoring them, but we haven't been finding the values for x because there's not been an equal sign. So that equal sign just keeps coming down. If it was equals 3, you'd have to keep the equals 3. When you have those problems when we first started doing arithmetic or solving, we didn't just go, okay, 3x, if I subtract 9, negative 16 is just nothing. We have to have that equals something. Okay. All right. Let's factor this. X. Signs are going to be different. So a plus and a minus. The factors of 3 that have a difference of 1.
Is 3 is on the negative and 2 is on the
3.
or 1.
And the 1 is with the positive.
How do you do it with the 3 up there? Like that.
It's not part of it. All we're looking at is the trinomial. Factor that. Now, you're still just looking, it's still 3 times this value. Whatever this value is, if it was 0, would make this whole thing equal to 0. So, x is equal to what?
Negative 1.
Is there anybody else that sounds like Kaylee?
Kelsey.
Kaylee Cuthbertson.
Oh, what? Negative 1.
Negative 1 and Chaosmus.
Do you not hear Kel?
And Taunton. Colton. Look at that. Cole.
We have a cold.
And Cole and Jack. Colatori.
Why don't you do the whole Morgan thing?
We've done that a couple times this year.
We have. Because we both answer at the same time sometimes.
Oh, that was
You
awesome.
could do
The one
Friday.
time we did this
Let's just do Friday.
like really quiet, you never answered.
My little cuz.
Cute, I didn't realize, 'cause I was looking at my book.
Yeah.
I answer the same role and not you all the time at church.
Mrs. Tucker is my cousin.
Yeah. And Pastor Paul, I knew
And
that.
I asked that answer.
She was a Clevenger.
I
She was.
realized
Yeah, I
that.
did not know that. I was like, what?
Is this Good Friday?
1 through 30. Plan on being due Friday. Yes. Test tomorrow. No, we won't test tomorrow. We'll test Friday.
So it's due Monday.
So it's due. Let's make it due Monday. Tell those other goobers that left early.
I don't have to take homework.
Could have done test too.
No.
What? Why not?
Already did that stupid thing.
I answered that clearly right here. No.
Oh, yeah.